Okay, everybody, we're gonna go over the homework first. I'm gonna check to see if this audio is working now because I did something. But anyway, if it's not, I gotta kind of spell things out because we got a lot of people gone. So, homework review. I want to answer questions. The first thing I want to do is talk about differences of two squares. I was hoping you guys would discover this on your own, but let me show you something like this. I don't know if this is one of the problems on there or not. I can't remember now. But, oh, is it? Okay. X squared minus 25 is what we call a difference of two squares. Last time I talked to you guys, I talked to you about perfect squares. Is x squared a perfect square? Yeah, because x times x makes x squared. Is 25 a perfect square? Yeah. So this one's x times x, and this one's 5 times 5, right? And is it a difference? Yeah, it's a minus sign, right? And so we call this a difference of two squares. They actually factor to be x minus 5 times x plus 5. Okay? Yes. So it actually factors to be x minus 5 times x plus 5. That's your answer. Now, everybody's saying, well, how does that work? Because usually when you multiply two binomials together, you get a trinomial, right? And I hoped you discovered this, that when you went x times x, you got x squared. X times 5, you got 5x. Negative 5 times x, you got negative 5x. And negative 5 times 5, you got negative 25. Well, what happened to them two middle terms, you guys? They added up to 0, didn't they? Okay. Does that make sense? Okay. That's what you guys should have learned on that. Now, okay. Was that a problem on there? Oh, yeah. Okay. All right. So that's kind of what we're doing. Now, there was one on there. No, it was like x squared minus 6. What number was that, you guys? Number 21. Okay. What's the problem with this one? 6 is not a perfect square, is it? But I wanted you to factor it like a perfect square instead of finding the square root of 6, because like the square root of 25 is 5, right? Since the square root of 6 is an irrational number, we don't want to write an irrational number, do we? Okay, we usually only do this when we have rational numbers, but we can still write it like this. X minus the square root of 6 times x plus the square root of 6. Does that make sense? Because, look, when I multiply them together, once again, watch. X times x is x squared. X times square root of 6 is x square root of 6. And negative 6 times square root of x is negative x square root of 6. And negative square root of 6 times negative square root of 6 is negative square root of 36. Which, what happens to the two middle terms again? They add up to 0. And what's the square root of 36? 6. And I come up with this, which was the same as that, right? So our answer is that right there. Okay? Any questions there? We got it? The other one I want to talk about was perfect square trinomials. I was hoping you would discover what perfect square trinomials were, okay? Because I gave you a few examples. I told you to multiply something together that was something like x plus 3 times x plus 3. What happens when you multiply two binomials together that are exactly the same? Well, you get x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Once again, your first term and your last term are perfect squares. Do you see that? That's a perfect square. And that is a perfect square, right? Those are both perfect squares. And what happens for the middle term? The two middle terms add up to what? 6x. And so in the middle terms, you guys, the middle terms are not going to add up to 0 when the signs are both the same, right? We get what we call a perfect square trinomial. What was that, Colby? 6 does not have a square root? Well, 6 doesn't. It's not a perfect square. If you take this up here and you times 1x, if you take 1x and times it by 3, you're going to get 3x, and then you double that number, and that's what's going to be the middle term. No, we call this a perfect square trinomial because what's the square root of this? This right here. You got two binomials exactly the same. When you take if you take the square root of, let's say, 25, you get 5 times 5, right? I mean, the answer is 5, but the factors are 5 and 5, right? Okay, so you get two factors that are exactly the same. So when I multiply 5 times 5 together, 5 times 5, I get 25. So 25 is a perfect square since its factors are both the same. Same here. This is a perfect square because its two factors are exactly the same. Got it? So those are what perfect square trinomials are, and differences of two squares. Okay, are there other questions you want to ask on the test? Kai, on the assignment. Which one? What does it ask? Picture frame 1? Okay, number 14. Picture frame. Picture. Okay. What are the dimensions of the picture? 4 by 6. What is the dimension of the frame? What's the width of the frame? X. Watch. X. And X, right? I'm going to add it over here too. X and X. Okay, I can't find the area of the picture plus the frame, can I? I cannot find that, but I can write an expression for it, right? Austin, what's the formula for area of a rectangle? Austin, you know this. I'm putting you on the spur of the moment here, so think. Area of a rectangle. Huh? There you go. See, I told you knew it. Okay? It's length and width. I put you on the spot there and you kind of froze up. So, you do that in basketball? No, you don't. All right. Okay. Area equals length times width, right? Okay. That's how you find the area of a rectangle. Well, I could find the area of the picture real easy. What do, you guys? 6 times 4. So, which is 24 square inches, right? For just the picture. But what about the picture frame? I want everybody to listen. Everybody's got to stop what you're doing and listen. Does anybody think they know the expression we can write? Andrea, what do you think? Close. Andrea said 4 plus x plus 6 plus 2x. Sarah. Taylor. Huh? Sarah. I keep getting you guys mixed up. The Joneses. Purple Jones. No. Okay, what did you say, Colby? What did you say, Colby? Well, you said it right just the first time. 4 plus 2x times what? 6 plus 2x. No. Look, you guys, how long is it from here to there? Well, it's that 4 plus that x and that x, right? You guys all see that? You're going to see lots of problems like this in your math careers. Okay? You're going to have to write an expression for this, and you have the then, how long is this length from here to here? That length right there. Well, you've got an x, a 6, plus another x makes 6 plus 2x, right? Do you see that? You got 4 plus 2x times 6 plus 2x. There's your length and width. There's my expression. Now, what does the rest of the problem ask you to do? Okay, there's our expression for the area of the picture. Then what? Identify the factors. What are the factors? 4 plus 2x and 6 plus 2x. Okay, then what? Okay, so we got to multiply them out and identify the monomial terms, right? So 4 times 6 is what? 24. 4 times 2x is 8x. 2x times 6 is 12x. And 2x times 2x is 4x squared, which, if we write in descending order, is 4x squared plus what? 20x plus what? 24. And so real terms are and 24. Those are my monomial terms. We got it? Okay. Any more questions you want to ask? It also asks for what? Okay, the coefficients. Does it really? Okay, what are the coefficients? 4 and 20 are numbers in front of the variables. So the coefficients would be 4 and 20. 4. Okay, take out your notes and write this down. Okay, this, I'm just going to review really quickly, difference of two squares. This is a formula for remembering the difference of two squares. A squared minus b squared is equal to, what would you guys say? Alex, what would you say? A squared minus b squared is equal to what? No. Think rather than think. Look at it. Difference of squares. A squared minus b squared equals? You're not Alex. A minus b times a plus b. We just went over this, right? Difference of two squares. So Alex, let me give you a second chance. What does that factor to be? Hey, can you guys let Alex think on his own? Yeah. For once. We're going to do it one more time. Okay, Alex. There you go. All right. I'm trying to help him out this whole time, and you guys just give him the answer. It's like giving handouts all the time. He never has to. Okay? All right, so it's like he's not on welfare here, Kai. All right, so here we go. All right, now, okay, that's the difference of two squares. You guys understand that? Yeah. Go back. All right, that's the difference of squares. I'm going to pause this for a second. Okay, next thing. We are going to do a sum of two cubes. This is a formula for the sum of two cubes. You have a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Okay, now that formula. Before we do that, I want to talk about perfect cubes. Can any of you guys name me a few perfect cubes? What's the very first one? No, that's the second one. 1 is the first one. 1 times 1 times 1 is 1. So 1 cubed is 1. Then 2 times 2 times 2 is 8. Then 3 times 3 times 3 is 27. So just, I got to write this down for those people watching at home. Right? What about 4 cubed? 64. What about 5 cubed? What about 6 cubed? Probably ought to write a few more down. What about 7 cubed? What is it? 343. 8 cubed. 512. 9 cubed. 729 and 10 cubed. I would write these down so that you have them when we're doing the assignment today, because you're going to know perfect cubes. You might experience cubes higher than this sometimes, perfect cubes higher than this, but I'm going to erase these. You guys all got them? Okay, here we go. I'm going to give you a problem. Let's say x cubed plus 729. Isn't that one of the numbers? Okay. Is this a sum of 2 cubes? Is x cubed a perfect cube? Is 729 a perfect cube? Okay. Just in case my sound's not working, I gotta write this down for those at home. And what's this thing right here mean? It means we're adding, we're a sum, right? This is called a sum of 2 cubes. Everybody got that? That's called a sum of 2 cubes. Now, I can rewrite this problem x cubed, what cubed? 9 cubed? Okay. So it is in the form of this right up here. See now? Is the same as this. So now I am going to write the factored form. Okay, this is a formula for factoring a sum of 2 cubes. Wherever there's an a, what am I going to put, you guys? An x. And wherever there's a b, what am I going to put? A 9. So what's my a plus b is going to be? X plus 9. Everybody write that down. And right here, once again, wherever there's an a, what am I going to put? So what am I going to write? X squared minus x times 9, we would write as 9x plus b squared, 9 squared, which is 81. Can you guys handle that formula? Can you handle it? All right, raise your hand if you can handle this. All right, okay. Raise your hand if you can't handle this. All right. I'm not worried about you two. All right. Okay, now the Next one is a difference of cubes. Yeah, we did. We were done. Let's go back. So, let's go back to this. Can you factor this more? Are there two numbers you can times together and get 81 and add together and get 9? No. If I times this by this, I would get what I started with. I would get this. I would get x cubed plus 729. Did you guys hear that? That's a good. Kobe asked, don't we have to times this by this? Well, we just undid that. If I multiplied this by this, I would end up with this, what I started with. Because we're factoring. Some factoring breaks it down so you can simplify something more. Later on, when you guys learn are factoring, or you guys are simplifying rational expressions, you'll want to factor the numerator, factor the denominator, and see if anything cancels. And so you have to factor it to cancel. Okay? So that's why we're learning this, I guess. Okay. Back to difference of two cubes. Here's the formula for difference of two cubes. If I have a cubed minus b cubed, that is equal to a minus b times a squared plus ab plus b squared. Okay, this is called a difference of two cubes. Okay, right here, that is a perfect cube, right? Right there is a perfect cube. And right there is a difference. Got it? Okay, so let's say I have something like such. X cubed minus 125. X cubed minus 125. Do you think you guys can do this? It's the same as the sum of two cubes, except for the signs are a little bit different, right? I'm going to give you a minute on it, see if you can come up with it yourself. Well, okay, let's. So A is X and B is 5. Wherever there's an A, I'm going to put an X. Wherever there's a B, I'm going to put a 5. So my thing is X 5. Got it? And then X squared, because A is X, B is 5, X times 5 is 5X, plus 5 squared, which is 25. Think you guys got that? Yeah, there's one more thing I can teach. This is called a difference of two cubes, or a difference of cubes, okay? I have written on your assignment, right at the top, I've written the formulas for you, okay? And so you can just refer to them there. They're right there, okay? Kai. The formula is right here, and that's a positive 5. It's x cubed minus a positive 5. Okay? So that's positive 5. The sign in front is minus, but, okay? All right, next one. Yeah. Next one. We're going to do, I call them quadratic. Look-a-likes. Quadratic look-alikes. I wrote down a formula here. The formula looks like this. X to the 4th plus bx squared plus c equals u squared plus bu plus c. And that is if x squared equals u. Why? Okay. Well, here's why we do this. Because let's say I gave you a problem. I'm going to make one up. Here we go. Now, does this look like a quadratic equation, you guys? Does it look like a quadratic equation to you?
Yes.
It's kind of like x squared minus 4x minus 60. Do you guys know how to factor x squared minus 4x minus 60? Do you remember factoring a trinomial into two binomials? You find the two. What are two numbers I can times together and get negative 60? Just give me two numbers. Negative 6 times positive 10. If I went negative 6 times positive 10, that's a negative 60. What about when I add them together? What am I going to get? I'm going to get a positive 4. But what's this term right here? A negative 4. So what do I have to do? So it's going to be negative 10 and positive 6, right? So you can factor this like this. The problem is that's not an x squared. That's an x to the fourth. And this is an x squared. These are double. So what we do is we say, okay, what if right now I'm going to substitute u in for every x squared? Well, there's two x squareds right here, right? Minus 4 times x squared minus 60. If I make a substitution for u for every